Hello students, welcome to geography class. Today we'll discuss about an earthquake. Did you ever experience an earthquake? But why does it happen? And what is an earthquake? Earthquake is caused by the release of energy that generates waves which travels in all directions causing the shaking of earth. What is this energy? What kind of these waves are and what is the shaking of the earth? Let me explain about it. Earth is not just a one piece. It is made up of jigsaw puzzle of around 19 to 20 pieces, which are known as tectonic plates. These plates are placed on hot, partially molten layer of earth mantle. This is the reason why these plates are moving. These plates move around 1 to 10 centimeter each year, but every movement can't be felt. Sometimes these movements are so strong and can be felt with a lot of vibration, or it can destroy the entire city. This is known as earthquake. Earthquake occurs in the lithosphere region of the earth. It generates underneath the earth and it releases the energy across the point at which the earthquake occurs. Under the earth is called hypocenter or focus, and exact place above it at surface of earth is called epicenter. Zoologists use the device that can sense the waves created by the movement of the tectonic plates. These waves are known as seismic waves and the device is known as seismograph. The earth events are scaled according to magnitude of the shock are known as Richter scale. This magnitude relates to energy released during the earthquake. Magnitude is expressed in absolute numbers 0 to 10, where 0 is lowest, people feel nothing. 10 being the highest that can create severe destruction and loss of lives over a large. Let's know more about earthquake with the help of simulator. We can see on the screen it is an inner core of the earth. Then there is outer core, then mantle core, and then crust. Inner core is the innermost layer and it is like a spherical ball with radius 1250 kilometers. Temperature is 4500 to 5500 degrees Celsius. Facing pressure is 300 to 360 gigapascals. Next is outer core. It is of about 22 kilometer thickness. Temperature is same as core mantle layer. It is the semi-solid state of about 2900 kilometers thickness. This layer makes about 84% of Earth's total volume. Last layer is the crust, which is like an apple skin, which runs from 0 to 70 kilometer thickness, which from which 8 kilometer under sea and 32 kilometers under continents. It is the only 1% of the total Earth's mass. Let's choose any one point on it. This is a small town where we see the street view when we click on the Earth's layer. This grayish layer is crust and reddish one is mantle. See this box on the left side, this box that sees earthquake magnitude on Richter scale with 3 buttons. These buttons show the magnitude of earthquake. In intensity of the earth is between 0 to 2. It can be barely sensed. When intensity is more than 2 or less than 4, then we can feel minor vibrations. From 4 to 4.9, it is considered as small earthquake. If it is ranges from 5 to 5.9, then it is a moderate earthquake, and from ranges 6 to 6.9 are considered as strong earthquake, and sometimes if it is greater than 7, then it is major earthquake, which causes lot of destruction. These readings are recorded on a seismograph. Now let's observe what happens if it is between 4 to 4.9. Then this is the hypocenter. During the earthquake, two types of waves are generated. One is body waves and other is surface waves. What are these body waves? Body waves are waves that move through the interior of the earth, or we can say that through the body of the earth. When these waves started moving, these waves come across the surface rocks and generate the surface waves. Let's discuss in detail about body waves and surface waves. From this point, hypocenter, waves are released. These waves are called primary waves or P waves. Now what are P waves? These are seismic waves that shakens the ground back and forth in the same direction and opposite direction as the direction of the waves. P waves look like this. There are P waves. These are first to be recorded on seismograph. When these P waves hit the rocks, give rise to the new set of waves, which are known as S waves or secondary waves. These waves move toward the Earth's crust, and these are the tremors that we feel. S waves are the waves motion in a solid medium where the medium moves perpendicular direction of the waves. After P waves, these S waves are recorded. The S waves hit the surface and it started the earthquake. See here, earthquake has started. Now let's discuss about surface waves, which are the most destructive waves and it causes harm to the life. When 4 to 4.9 causes damage to nearby houses, but buildings are okay. Let's see what happens when magnitude is 5 to 5.9. Now there is more damage, small houses are shattered and buildings also have cracks. Remember one thing, the higher the magnitude, the closer the hypocenter to the epicenter. When we move to 6 to 6.9 magnitude, difference between hypocenter and epicenter is less and damage is enormous. Buildings are broken, roads are cracked. Earthquake is a really damaging natural calamity. This happened in case of magnitude, if it is greater than 7. What will happen if it is more than 7 or 9? It is difficult to predict earthquake based on seismic graph, but now our smartphone can detect it and scientists can use the data to predict it. So let's discuss how shadow zones are created. Emergence of shadow zones. Earthquake waves get recorded in seismic graphs located at far off locations. However, there exist some specific areas where waves are not reported. So, such a zone is known as shadow zone, where these waves are not recorded. The study of different events reveals that for each earthquake there exists an altogether different shadow zones. I'll show you figure. In those figures, figure A and figure B show the shadow zones of P and S waves. If you see these two diagrams, you will notice the P wave shadow zone and S wave shadow zone. This is diagram A, this is diagram B. In this diagram, here, this area, you will see that this is P wave shadow zone. This is between 105 to 142 degree. And this is S wave shadow zone. Let's discuss shadow zones of P waves and S waves. The seismic graph located beyond 145 degree from the epicenter. What is epicenter? I have explained all the terms in my last video, so please see that video. Record the arrival of P waves, but not that of S waves. See here, beyond 145 degree from epicenter. Here only arrival of P waves are recorded, not S waves. So, zone between 105 degree and 145 degree from epicenter was identified as the shadow zone for both the types of waves. The entire zone beyond 105 degree does not receive S waves. Shadow zone of S wave is much larger than P waves, and shadow zone of P waves appears as a band around the earth between 105 degree and 145 degree away from the epicenter. Now let's discuss types of earthquake. The first one are the tectonic earthquakes. These are generated due to sliding of rocks along the fault plane. These are the common ones. Second are volcanic earthquakes. This is a special class of tectonic earthquakes is sometimes recognized as a volcanic earthquake. However, these are confined to areas of active volcanoes, means only in those areas where volcanoes are active. Third, collapse earthquakes. In the areas of intense mining activities. Keep it in mind where mining activities are done. Sometimes the roofs of underground mines collapse, causing minor tremor. These are known as collapse earthquakes. Fourth is explosion earthquake. So what you will do in explosion earthquake, how will you explain? Ground shaking may also occur due to the explosion of chemical or nuclear devices. So such tremors are known as explosion earthquakes. Next is reservoir induced earthquakes. These earthquakes that occur in the areas of large reservoirs are referred to as reservoir induced earthquakes. Now let's discuss the effects of earthquakes. Earthquake is a natural hazard. The following are the immediate hazardous effects of earthquake: ground shaking, differential ground settlement, land and mudslides, soil liquefaction, ground lurching, avalanches, ground displacement, floods from dam and levee failure, fires, structural collapse, falling objects, and tsunami. Now, we will discuss all these effects with the help of diagrams. This is the picture of landslide. Landslide is defined as the movement of a mass of rock, debris, or earth down a slope. This is ground rupture after shaking of earth. Surface rupture is visible offset of ground surface when an earthquake rupture along a fault affects the earth's surface. Earthquake can cause fires by damaging electrical powers or gas lines. Here you can see a picture of tsunami after earthquake. Although tsunamis occur most often in the Pacific Ocean, they can be generated by major earthquakes in other areas. The most frequent cause of tsunami is crustal movement along the fault. This fault. A large mass of rock drops or rises and displaces the column of water. See here in this picture, raises the column of water above it. This column of water is tsunami. You can see floods here. It is caused by shaking motion of earthquakes causing saturated or partially saturated soil to lose strength and rigidity. Water contained in the soil subject to liquefaction also. Here you can see soil liquefaction frequently rises to the surface. And liquefaction is what? When the surface loses its strength and stiffness. In this picture, there are two different diagrams. You will see stable soil here, and here it is liquefied soil, about which we are talking. Shaking and tilting causes some structures to fail. Here you will see this is bedrock, this is topsoil, and same here, bedrock, rock soil. But these structures, you will see these structures are damaged. So thank you so much. I hope you will like this video. If you like this video, then hit the like button and subscribe my channel. Thank you once again. Take care.